Hey everyone, welcome to our next video. So this one is going to be 1.4. So 1.4 is quadratic equations. And there's a few different ways that you can solve quadratic equations. Also, let me point out to you, quadratics are in the form ax squared plus bx plus c, and usually we're going to want them equal to 0. So as you do these, there's a few different ways. The first way that we should always try, because it's kind of the best, is factoring. Now we've already talked about factoring in one of our review sections, so I won't go over it too much. I'll just do a couple of these, and we won't go over really the factoring part of it as much as the stuff that, like the setting equal to, and I don't know. Hopefully it'll make sense when I just do it. So after factoring, we set each, I'll just say like part equal to 0. Now the first thing with factoring is you must be equal to 0 to be able to factor. So if you're not equal to 0, then we got to do something about that. So example 1, I'll say solve for the missing variable. First one, let's do x squared minus 9 equals 0. B, let's do x squared minus 8x equals 0. Do I need more space in this? Maybe. So I'll leave it here for now. So for our first one, x squared minus 9, first we check, is it equal to 0? Yes, then we can factor one side. Now if you can't factor, then we're going to have some other methods that we can use. So x squared minus 9 factors into x plus 3, x minus 3. Then we can set each parentheses equal to 0, so we get x plus 3 equals 0, x minus 3 equals 0. And then I can solve each equation kind of like a linear equation. So it'd be x equals negative 3 and x equals 3. All right. And I think that y'all can kind of do some of these by yourself and just kind of see where you get. But for the next one, so I do notice, and you should always check for this first, I have a GCF. So that means I can take out an x. So I'd be left with x minus 8 equal to 0. So then for each part, I have x equals 0, and I have x minus 8 equals 0. So this one gives me x equals 8. So both of these are answers. So you have to be careful sometimes, because what I've seen in the past is sometimes people try to like divide by x. You never want to divide by a variable. You can factor out a variable, but never ever divide by a variable. Let's do some more. C, we'll do x plus 3, x minus 4 equals 8. And then D, we'll do 4x squared minus 14x equals negative 12. So for part C, I'm not equal to 0. So that's a problem. So if I'm not equal to 0, I need to move that 8 over to the left side. Well, I can't combine anything right now, so I'm going to need to expand this out, move over the 8, and then refactor. So pause and go ahead and do that yourself. But I'm going to expand this out on the left side, so I get x squared plus 3x minus 4x minus 12 equals 8. And then I'm going to move over that 8 so that I'm equal to 0. So I'm going to subtract 8 from both sides. This gives me x squared minus x minus 20 equals 0. Now that I'm equal to 0, I can try to factor this. So I need two things that multiply to negative 20 but would add together to negative 1. So that's going to give me x minus 5, x plus 4. Set each parentheses equal to 0. So I get x equals 5 and x equals negative 4. Just a little side thing here. Whenever you're setting equal to 0, the reason is because for two things to multiply and equal 0, at least one of those things had to be 0, right? Because the only way to multiply to get 0 is to multiply by 0. The issue is when it's written like this, so when you're leaving it equal to 8, the problem is some people will write this. They'll do, okay, so x plus 3 must equal 8 and x minus 4 equals 8. Okay, if both of these equal 8, how are they multiplying to equal 8? They would multiply to equal 64. So that doesn't make any sense. So that's why you need it equal to 0. And let's do part D. So part D, I need it equal to 0. So I'm going to move that 12 over. 4x squared minus 14x is going to be plus 12 equals 0. Always check for a GCF. Is there anything maybe I can take out of all this? And it would be a 2. So I can factor out a 2. I'm left with 2x squared minus 7x plus 6. Now, if you want to divide by that 2 to get rid of it, that's okay. You can do that. You don't want to divide by variables. But if we want to just get rid of like a number or something, that's okay. So we can get rid of that 2 in the front. Only because it was a number. If there was an x or something, we would not have done that. So I have 2x squared minus 7x plus 6 equals 0. So let me factor this. So I'm going to have 2x and x here. My signs are going to have to both be negative since I'm trying to get to a positive number multiplied, but I'm adding to a negative, so they'll have to both be negative. Since my numbers are pretty close together, like 7 and 6 are close together, I'm probably going to pick numbers that are close together. So if I think about 6, I can either do 6 and 1 or 2 and 3. If I put a 2 here and a 3 here, I'm thinking ahead to how I can expand this. So it'd be 2x squared plus 4, oh sorry, minus 4x minus 3x plus 6. Okay, that minus 4 minus 3 gave me the 7. So that's what I was looking for. Now remember, there are other ways to factor something with a not equal to 1. If you need help with that, please let me know. In the other video I made about factoring, I think that was R5. I did show you another method. So I get 2x minus 3 equals 0, x minus 2 equals 0. So this is going to give me 2x equals 3. So x equals 3 over 2. And this one's going to give me x equals 2. Alrighty, so that's all I'm really going to do for factoring. My second way I can solve quadratics is the square root property. Now this can't always be used. Neither can factoring really, but the square root property can be used. The best way to explain it is if you're just seeing the x squared, you're not seeing like an x by itself. What I mean by that is, let's say so I'll show you an example. And I'll just say solve. But if I have x squared minus 9 equals 0, this is a good candidate for the square root property because I only see the x squared. I don't have like an x by itself, like these, like C and D. Another good candidate for this would be something like this. 2x minus 1 squared equals 0. But something like, let's say if it said like 2x squared plus x, okay, this is not a good candidate for square root property because if I try to take the square root of both sides, this plus x is in my way. Or let's say I try to move it to the other side. Okay, well then if I take the square root of both sides, I end up with square root of negative x. That's not trying to help me at all, you know? So that's a case where you would want to do GCF. So sometimes square root property can be useful, sometimes it's not. But let me show you how to use it. So you have to get the squared by itself first. So get the squared alone. So if I move this 9 over to the other side, I get x squared equals 9. Then I can take the square root of both sides, and it cancels out on the x squared, so it just leaves me with x. You have to be careful though. Whenever you take the square root, it's plus or minus. That's really important to remember. So plus or minus the square root of 9. Square root of 9 is 3. So I get plus or minus 3. And now the reason that it's plus or minus is you got to think back to what it's the opposite of. It's the opposite of squaring something. So for instance, negative 3 squared is 9, and so is positive 3 squared. So both of them work. So you want to make sure whenever you take square roots that it's plus or minus. Very, very important. Let's do b together. So this one, the squared is already by itself. So I can take the square root of both sides. It's still plus or minus. It cancels out on the left, so I'm left with 2x minus 1. Plus or minus the square root of 0 is just 0. So it was good to write it so that we're in the habit, but it ended up not mattering. Then I get 2x equals 1, so x equals 1/2. Let me go ahead and make another one of these. So this will be example C for this one. This one says x minus 3 squared plus 8 equals 0. So I need to get the squared by itself. Now, let me give you a little thing here. If there was an x on this 8, we would not want to use square root property. We'd probably want to expand, add everything out, combine like terms, and maybe try to factor or something like that. But because we can get the squared completely alone, and there isn't like an x by itself, not associated with the squared, that's why we can use it. So I can move that 8 over and have negative 8 on that side. Take the square root of both sides, remember plus or minus. Now it cancels out on the left, so I'm left with x minus 3 equals, and square root of negative 8, I can simplify that. So it ends up as I root 8. We can simplify that further though, because 8 can split up into 4 and 2. Come up here. So square root of 4 is 2i, and then I have that root 2. So be prepared to simplify those roots. Then I need to solve for the x. I can add 3 to both sides. I end up with x equals 3 plus or minus 2i root 2. Now I'm fine with you either leaving your answer like this, or if you want to maybe split them up and say x equals 3 minus 2i root 2 and x equals 3 plus 2i root 2. You can do either one, however you want to leave your final answer. I'm okay with either one. They're both right. All right. Next, we're going to look into completing the square. Now, completing the square is one of my favorites. It is one of my favorite methods. I'm debating on whether I want to show you the proof or not for completing the square. I kind of think I do. All right, let's do it. Let's show you the proof for this. So here's the idea for completing the square. Let's say we start with a square, and I'm going to say it's an x by x. So I'm starting with x squared, right? Because that's the volume of that. I'm sorry, not volume, area. And then I say, okay, let's add on a piece here, and let's say that it's b by x. So we're going to add on bx. I want to know, how much do I need to add on to this so that it becomes a square again? Because I just turned this into a rectangle. What we can do is we can split this piece that we added. We can divide it by 2. So that means that this little piece here will be b over 2 by x, and this little piece will be b over 2 by x. Then I'm going to like redistribute it. So let's see. I still have my x by x, and I'm going to draw one part of this b over 2 by x, and I'm going to draw the other half, that's a little wide, on the other side, and that's also b over 2 by x. So to make this a perfect square again, I really just need this little box right here, where this little box is b over 2 by b over 2. So to make this a perfect square, I need to add b over 2 squared, because that would be the area of that little box. So this is essentially the proof of completing the square. And the whole point of this is so that we can factor into something that'll end up as b plus b over 2 squared. And so that makes it a perfect square. And then the other point is that once you have it as a perfect square, you can use square root property. So usually completing the square is used on things where you can't factor it, but you you can't factor it, but you can try to do some other stuff with it, like completing the square. And then for the last one, we will talk about also quadratic formula. But complete the square is not just used for solving. Complete the square is also used later whenever we start graphing um, quadratic functions. We'll use complete the square again later. So it's not something that you should just say, oh, well, I don't have to learn this method. I can use quadratic formula no matter what. No. One, I'm going to ask you to specifically use this method on the test, and it comes up later. So you don't want to miss out on it. So let me go ahead and show you with some numbers and stuff like that. And just as a little part here, this could also be minus, like here. So it's either a plus or a minus. You either want to add bx or you want to subtract a bx. So let me show you an example. I'll just say solve. And the first one is x squared plus 6x plus 7 equals 0. So the issue here is it can't factor. So since it can't factor, what we want to do is we're basically saying, okay, that plus 7 right there is really an issue. If it wasn't a plus 7, maybe if it was something else, maybe this would be able to factor. And that's true. So what I like to do first is I like to move over anything that doesn't have the x. So I'm going to move over, I'm going to leave a space here. I'm going to move over that 7. So now it's negative 7 over there. Now in these spots here, I want to think, what could I add so that I can make something that looks like this? So that's what I want to think about. I want to think about what could I add right there so that I could factor that side. Well, in the proof, I showed you what you need to add. You need to add b over 2 squared. The b value is your number in front of the x. So for us, we're going to add, so b over 2 squared is 6 over 2 squared, which is 3 squared, which is 9. So we're going to add 9 right here. Now be careful, be careful. You have to add it to the other side as well. Because whatever you do to one side, you got to do to the other. So we had to add 9 on both sides. Okay? Now I'm coming here. Now I'm going to factor that left side. So if I factor that, it factors into x plus 3, x plus 3. And then on the other side here, I have negative 7 plus 9. So that's 2. X plus 3, x plus 3. So that's just x plus 3 squared. So that's what I wanted. I wanted something that looks like this. That way, I can use square root property. Also, a little note here. You see how it was the 3? Oh, sorry, I didn't mean to erase that. You see how it was the 3 that ended up here? I wrote it up for you up here as well. It's just the b over 2. So it's before you square it. So it's all in the proof. I'll point it out for you in another example as well. But now I'm going to use square root property. So if I take the square root of both sides, don't forget plus or minus. This cancels. I'm left with x plus 3 equals plus or minus square root 2. Subtract 3 from both sides. That gives me x is equal to negative 3 plus or minus square root 2. And you can either write it like this, or you can split it up if you want to. I just love complete the square. I think it's so, I don't know, just neat. And it's so helpful later for us. We're even going to do complete the square when we do circles. So there's multiple sections that we'll come up on that we're going to have to use complete the square. So pretty important. Let's do some more. So for part B, I'm going to give you another one. And for this one, I recommend trying it on your own. So you should pause and try to do it by yourself. I will say that if the b value is not even, sometimes this can get a little tricky. It's not impossible. You can still do it. It's just they're not as nice. Maybe I'll do one where like the b isn't even. It's just because you got to do b over 2 and then square it. So if the b over 2, like if you can't divide it by 2, you end up with fractions. So it can be a little annoying. But fractions are okay. Don't freak out about them. Alrighty, let's do B together. So take a minute. You should do it yourself, but now I'm going to do it. So my issue is this 4. This 4 is bad. So I'm going to move it over. And I want to replace it with something else. So I'm going to put something else right here. The way you find out what to put is you do B over 2 squared. So this is going to be negative 10 over 2 squared, negative 5 squared, so 25. So if I add 25 to both sides, make sure you do it to both, because whatever you do to one side, you got to do to the other. So then I'm going to factor. This side factors into x, look right here, minus 5 squared. Because it would be x minus 5, so x minus 5 squared. Equals, and on the other side now I have 29. Now I can take the square root of both sides. So remember, always plus or minus. Come over here. I get x minus 5 equals plus or minus the square root of 29. And then I can add 5 to both sides. So there we go. Beautiful. And you can end up with I as well. Like that can happen even with complete the square. Now in all the ones we've done so far, the a value, like the value in front of the x squared, has been 1. So if a is not equal to 1, you first divide by your a value. So of course, let's do one like that together. So part C, we're going to do 2x squared minus 4x minus 1 equals 0. Since my a value is not 1, for my first step, I'm going to divide everything in here by 2. So this will give me x squared minus 2x minus 1/2 equals 0. Now I just treat it the same. So just like the others, I move over that like c value because that's not going to be in my factored part. Like that's messing up my factoring. So I need to move that over. So I get x squared minus 2x. I want to add something else right here, and I'm going to move over that half to the other side. To figure out what I add to both sides, it's b over 2 squared. So negative 2 over 2 squared, negative 1 squared, so 1. So I'm adding 1 to both sides. Now on the left, this is going to factor into, you can think about it, it'd be x minus 1, or just x minus 1 squared. Again, it's whatever this is, minus 1. So I get a half plus, now it's plus 1, so I'm going to write that as 2 over 2. Let me come up here. So then I have x minus 1 squared equals 3 over 2. Square root property. So I get x minus 1 equals plus or minus the square root of 3 over 2. Move over the 1. And I'm done. Now if that root could like simplify it all, you would definitely want to, but it can't, so we'll just leave it as it is. Cool. So that's it for completing the square. Now let's talk about quadratic formula. I feel like I'm very enthusiastic today while I'm making this video. It's because I had caffeine, I think. I'm not really a caffeine drinker, so I feel like honestly super awake right now, which usually I'm very tired at this time. So if you're like, wow, she is wired in this video, I feel that way. All right, so quadratic formula. The nice thing about quadratic formula is it always works. So that's always nice. You can use it for every quadratic. Um, but it's not the best way, even though it always works. Really factoring is the nicest. But the reason is because as you do quadratic formula, sometimes you end up with things like you end up with big numbers like in the process. So not always the most beneficial, but it is nice to have a method that always works. So a reminder, it starts off as ax squared plus bx plus c, and you need it equal to 0. Just like with factoring, we need it equal to 0. Then your quadratic formula says x equals negative b plus or minus square root b squared minus 4ac, all divided by 2a. So let's do a few like this, using this method. So usually you're going to want to factor, and then I would usually recommend complete the square. And then if that doesn't work, I would say quadratic formula. Like I would only use that as like last resort. But yeah, it's up to you really. Unless I ask for a certain method. If on the test I like specifically say like factor or complete the square, you need to do that to receive full credit. So be careful. So let's do some examples. So example 4, I just say solve. And we'll do x squared minus 4x plus 9 equals 0. We'll do that one first. Then we'll do negative 2x squared plus 5 equals negative 3x. And I'll probably run out of room if I try to write more on the same page. So now this is something I didn't mention earlier. If you have a negative in front of your x squared and you want to try to like factor or something, you can just move it all to the other side or multiply by negative 1. And then you don't have the negative anymore. So that's something for factoring that I didn't show. All right, so first step, for part A, I would actually probably do complete the square on this. The reason is because this b value is it's even, so complete the square would actually work pretty nicely. But we're just going to do it the other way just because. So my a value here is 1, my b is negative 4, my c is 9. X should never be involved in your A, B, or C. Your A, B, and C are constants. So they're like your coefficients or your constant. They're not, they don't have a variable in there. So let me plug this into my formula. Negative B, so that's going to be negative negative 4 plus or minus square root negative 4 squared minus 4 times 1 times 9. All divided by 2 times 1. So I plug everything in. And then I simplify. So I get positive 4 plus or minus the square root. Negative 4 squared is 16 minus 36, all divided by 2. Keep on going. So I get 4 plus or minus the square root. 16 minus 36 is going to give me negative 20 all over 2. I got to keep on simplifying. So 4 plus or minus negative 20 simplifies into 2I root 5. And this is all over 2. I'm still not done. Since the 2 on the bottom, like I can do 4 over 2 and I can do 2 over 2, I can actually simplify this further. Now, if let's say this 2 right here wasn't here, I would just box in where I'm at. I would not want to go any further. But because that 2 is there, and since both terms can divide that 2, that's why we want to do it. So if you want, you could split it up to be careful. So this is 4 over 2 plus or minus 2I root 5 over 2. So I get 2 plus or minus I root 5. That's my final answer. If you do not fully simplify, you can lose credit on the test. So be aware of that. All right, let's go to part B. Part B is in a weird order. Make sure you write it as like ax squared plus bx plus c. So I'm going to move over that 3x. So plus 3x plus 5 equals 0. So my a is negative 2, b is 3, c is 5. This is actually a really good example of one that I would totally use quadratic formula on, because if I don't, this one's going to be a pain to use complete the square or something like that on, because there's no way to factor it, like it's not factorable. And then if I try to complete the square, I got to divide everything by negative 2. So then I'll have 3 over negative 2, and then I have to do that divided by 2 and then square. No way. No way. We're not doing that. This is a good one to use quadratic formula for. So I'm going to put everything into my formula. So here it is up here. So I have negative 3 plus or minus the square root 3 squared minus 4 times negative 2 times 5, all divided by 2 times negative 2. The rest of it's just simplifying, really. So negative 3 plus or minus, I get 9 plus, that's 8 times 5, so that's going to be 40 divided by negative 4. So I get negative 3 plus or minus the square root of 49 divided by negative 4. Keep on going. Negative 3 plus or minus. Square root of 49 is 7 over negative 4. Now, because these are all numbers, you want to keep simplifying. So I'm going to split them up. If you don't fully simplify this, you can lose credit. If it's left as like this one right here, we had to leave it because it's with I. Or like if it has square roots, you have to leave it ugly. But if it's all numbers like this, you really should keep going. So this is x equals negative 3 minus 7 divided by negative 4. And x equals negative 3 plus 7 divided by negative 4. So these can become just like numbers. So that's why you want to do it. So negative 3 minus 7 is negative 10 over negative 4, which simplifies further into 5 over 2. And then this one becomes 4 over negative 4, right? Negative 3 plus 7 is 4. I'm not crazy, right? Yeah. So I get x equals negative 1. And that is fully simplified. Cool. Sorry, I was kind of silent for a second. It's because I wrote something weird in my notes, but it's because I wrote my answer wrong somewhere. But I'm trying to make sure that I didn't just make a mistake with you, but that my notes have a mistake, because that happens all the time. Whenever I'm just going, I make mistakes all the time for those. Yeah, it definitely looks like there's a mistake in my notes. So I'm not going to worry about it. If there is a mistake in this one, if you find one, please let me know and I'll make a correction when I make the next video or something. Alrighty, I want to do one more example of quadratic formula. So this one is negative 2x squared. I might not finish it out completely, but I just want to start it off. I just wanted to show you if maybe there isn't, if there's a missing part. So for this one, I'm still in the ax squared plus bx plus c form, but I don't have a bx. So my a is negative 2, my b in this is just 0, and then my c is 5. If it helps, you could always rewrite it with the 0x in there. But I just wanted to make that point to you. I think you could do it after this, but if there's a piece missing, it's just that the coefficient there would be 0. So that's fine. And you could finish that one. One more thing that I want to show you about quadratic formula is this part of the quadratic formula is called the discriminant. So it has a special name. And the answer to quadratics, how many answers there are, is determined by the discriminant. So the discriminant, I don't know if I'm spelling this right. Sorry if I'm spelling it wrong, but the discriminant determines how many answers we get. So quadratics can have 0 real solutions. It can have 1 real solution. Or it can have 2 real solutions. And we've already seen that. So let me highlight some places for you. So this one right here, part B of example 4, that's 2 real solutions. Part A is 2 imaginary solutions or complex solutions. So that's 0 real solutions. If I look up here, did I do any that have 1 real solution? Yeah, part B of example 2. Example 2, part B. So quadratics, you see how it's an x squared is their highest power? They can have at most 2 real solutions. So for instance, like if the highest power is 3 on like a polynomial, then you could have at most 3 real solutions. If the highest exponent is 50 on a polynomial, you could have at most 50 real solutions. Now that's at most. You're not guaranteed to have that many. So let me show you what this looks like. So your first option, if b squared, oh, I'm so sorry. Get rid of the square root when you're talking about the discriminant. I accidentally put the square root in there. B squared minus 4ac. If this is less than 0, then we have no real roots. And I want us to think about like why that happens. So in the quadratic formula, we have to take the square root of this. So if it's less than 0, then that means it's negative. So you're taking the square root of a negative number. So you're getting complex solutions, no real solutions. Your second option is if it's equal to 0. Then you'll have one real solution or real root. Sometimes we call the solutions or roots or zeros. And again, think about why this happens. In the quadratic formula, you're going to have to take the square root of 0. Well, it's plus or minus 0, so it goes away. So that's why the plus or minus is what gives you the two solutions. So if you just do plus or minus 0, you don't get anything. And then the third one, if your b squared minus 4ac is bigger than 0, so it's positive, then you'll have two real roots or solutions, whatever you want to call them. Oh, this is so funny. I did misspell discriminant. Sorry, I'm kind of all over the place. This is honestly why I don't drink coffee. Not coffee, caffeine. I misspelled discriminant. And I literally wrote it in my notes if I had just paid attention. Sorry about that. Sorry about that. I would never re-record a whole video just because I made a spelling mistake. I'll just accept it. Okay, so some things to just kind of recap this section. Quadratics can have three options. They can either have no real solutions, which means they're going to have imaginary solutions. They can have one real solution, or they can have two real solutions. The discriminant can tell you how many they have. Quadratic formula is a last resort. It's really better. One, you should always try factoring. Or square root property. If neither of those are possible, I would say complete the square. Now, if you're going to end up with a bunch of ugly fractions when you try completing the square, that's when I would probably try quadratic formula. So it's kind of like you either try methods 1 or 2, then you try 3. Okay, none of that works. Then you can do number 4. Now, overall, for the most part, it is going to be up to you in your solving quadratics life, what you choose to do. But on the test, I do get picky about method, so that's something to remember. Sorry if I talked a little fast in this video. I do have to like go right now so I didn't have that long like to record my video. So I just wanted to tell you guys to have a good day, and yeah, just let me know if you have any questions. I know I always say that, but it really is important to me that you guys know that you can ask me about any of this information, and I'll never judge you or anything. I mean, you see me make mistakes, and I couldn't even spell, even though it was literally right in front of me how to spell it. So don't ever feel bad about asking me, okay? Again, yeah, hope y'all have a good day.